We will be using the equation of change in y over change in x. This is another way that sometimes you will come across it, is they will show y, the second y minus the first y over the second x minus the first x. And I will explain that, but we have found through practicing this numerous times that actually it doesn't matter which y we subtract as long as we keep them in the same order. Okay, so sometimes they are going to go ahead and give us a table of coordinates. So what I want you to realize is when you get a table like this set right here is kind of like it's written out as 1, 8. These are our x's and these are our y's. Okay, so we're going to use two sets of the 4 that we have here. So I'm going to go ahead and use the first one and the second one. So when I do a change, that means that I'm subtracting between them. So here, I'm a left to right person, so I'm going to go ahead and just work left to right. And then I'll also reverse it just to prove that we're going to get the same answer either way. So here, if I do a change, I'm going to do 1 minus 4 and 8 minus 6. Now, the key thing is that you have to remember, because I'm guilty of sometimes making this mistake, is we have to do our change in y's first, because when we do slope, it's rise over run. So rise kind of sounds like y's. So it has to be the y's over the x's. So our change in y's, we've got 8 minus 6. Well, that gives us 2. Over, we have to stay in the same order. Since I worked left to right, I have to do that in this set also. So 1 minus 4. Okay, so 1 minus 4 would give me negative 3. I just found out that the slope to this line is actually negative 2/3. Okay, it doesn't matter that that negative was in front of the 3. It makes the whole fraction negative, or the whole slope. Okay, so let's say I didn't know which one to put first, and I had used the 4 minus the 1 and the 6 minus the 8. So I'm going to go ahead and show you what would happen if we had done where they did the second y minus the first y. So if I were to work the opposite direction, so here if I did this, 6 minus 8 over 4 minus 1. Now, the key thing is whatever order you decide to go, you must do that in both of your sets. You can't move left to right on one of them and right to left on the other. So here, if I go through and I subtract it out, 6 minus 8 is going to give me negative 2 over 4 minus 1 is 3. So notice, this time I had the negative in front of the 2, but I told you before that one negative makes the whole fraction negative. So we still are going to end up with this negative 2/3. Okay, and we could pick any points, any two sets. So just to prove that, we're going to go ahead and pick two other sets off of the same set of numbers. So maybe I'm going to do, I don't know, these two. And if I picked ones that weren't right next to each other, it just means that I'm going to have to actually end up reducing. So here, I like to work left to right. So I'm going to work this way. So remember, the y's are the rise. Those are the top ones. So 4 minus 2 over 7 minus 10. So 4 minus 2 is 2. 7 minus 10 gives me negative 3. So see how we still end up with one negative? We're still getting 2/3 with one negative, or a negative 2/3. So it doesn't matter which 2 points you pick. As long as you use the coordinates of those points, you're going to get the same slope. Okay, so let's try another set, another table here. Okay, so looking at this one, we're going to pick two sets. So maybe I'm going to pick, I don't know, we'll pick the first two. The reason being is because there's negatives in there, so I'd like to kind of cover something with the negatives. Okay, so when I look at this one, I'm going to go ahead and put my minus signs between these, and I'm going to work left to right. Okay, so my y's have to go on the top. That's my rise. So 6 minus 4 over negative 3. And a lot of people forget this because, oh, that 2 has a negative. they tend to forget to write the minus a negative 2. So you have to remember to put that minus in there, even though there's a negative in front of that 2, because it ends up changing the 2. So now this becomes 6 minus 4, which is going to give me 2, over negative 3 plus 2 now. Those two negatives make a plus sign. So negative 3 plus 2 is going to give me negative 1. So we just found out that our slope is negative 2 over 1, which is the same as just a negative 2. So that negative applies to our final answer. Okay, we would get the same thing if we worked off of sometimes a strategy. If you have any of your coordinates where it's a set of zeros, so like here I'm noticing this. If I were to work left to right, 2 minus 0 gives me 2, and negative 1 minus 0 gives me negative 1. It's just very easy, quick math. So sometimes there is strategy in the coordinates that you pick. Okay, so that's working off of the table. So I'm going to go ahead and slide a table out and have you guys try one on your own. Okay, so go ahead and try this table. Pick 2 sets of the XYs, and you're going to go ahead and do your change in Y, which are your reds, over your change in X. So go ahead and pause the video and work your way through that, and then check yourself in just a minute. You should have ended up with 2/3. If you worked left to right on this one, it shouldn't have been 2/3. Sorry, what did I do? I messed up my XY because I looked at it and tried to do the top and bottom. It should have been 3 over 2. But if you looked at this, if you worked left to right, you got negatives. So you had negative 3 over negative 2. Remember, 2 negatives make it a positive. So we ended up with, you should have gotten a positive 3 over 2. Okay, so that's working off of a table. Sometimes they give you a table.